So let's go ahead and prove the following trigonometric identities, which is given in question 5 under the exercise 8.4. So first is cosec theta minus cot theta bracket square is equals to 1 minus cos theta divided by 1 plus cos theta. So I have given you both the methods to prove it, whether either you can solve LHS, that is left hand side part of the equation, and equate or make it or equate it with the RHS, or else you can also find it by solving the right hand side part of the equation and then equating it with the left hand side. So let's first check the method 1 by solving the LHS. So LHS is cosec theta minus cot theta bracket square. So we know cosec theta is 1 upon sine theta and cot theta is 1 upon tan theta, that is 1 upon 1 upon sine theta upon cos theta, which is equals to cos theta upon sine theta. So substituting these values, we'll get 1 divided by sine theta minus cos theta divided by sine theta bracket square. So ahead we are taking sine theta, so we are just making the square separately to the numerator and denominator. We'll get 1 minus cos theta bracket square divided by sine square theta. Now we know the trigonometric identity where sine square theta plus cos square theta is equals to 1. So if we shift the cos square theta to the other side, so we'll get the sine square theta is equals to 1 minus cos square theta. So 1 minus, so substituting these values, so we'll get 1 minus cos theta bracket square divided by 1 minus cos square theta. So if you look at the denominator, that is 1 minus cos square theta, so 1 square is 1, right? And then minus cos theta square is cos square theta. So this is nothing but the a square minus b square, we are getting it. So we can split it into a plus b in one bracket and we can multiply it with the other bracket as in a minus b. Okay, so applying this property in the denominator, and in numerator we can see it is the square of a minus b, like the a minus b bracket square. So we can also split this in a minus b into a minus b. Okay, or the actual formula is a square minus 2ab plus b square, and we are getting, like we have found this before, right, that we can find this formula using one in first bracket a minus b into the second bracket a minus b. So applying this both the properties, we'll get 1 minus cos theta into 1 minus cos theta divided by 1 plus cos theta into 1 minus cos theta. Now we got the similar values in numerator and denominator as 1 minus cos theta, which we are cancelling it out, and we're left with 1 minus cos theta divided by 1 plus cos theta, which is the right hand side part of the equation, hence proved. Now let's also check the method 2 by solving the right hand side. So RHS is equals to 1 minus cos theta upon 1 plus cos theta. So we are just multiplying numerator and denominator by 1 minus cos theta. So post multiplication we'll get 1 minus cos theta bracket square divided by 1 minus cos square theta. How we got this? Because a minus b into a minus b will be equal to a minus b bracket square, and a plus b into a minus b will be equal to a square minus b square. Okay, so so we know the trigonometric identity, which is sine square theta plus cos square theta is equals to 1. So if we shift the cos square theta to the other side, we'll get the sine square theta value as 1 minus cos square theta. So the denominator of this question here is 1 minus cos square theta, which is nothing but the sine square theta. So we are just substituting sine square theta in the place of 1 minus cos square theta. So we'll get 1 minus cos theta bracket square divided by sine square theta. So if we look at the numerator and denominator, both has the squares, the whole squares, right? So we can write it by making one common bracket for 1 minus cos theta divided by sine theta, and then bracket the whole bracket square. So again we can split this 1 minus cos theta into 1 divided by sine theta minus cos theta divided by sine theta. if we'll reverse back the step and if we'll take the LCM of 1 divided by sine theta minus cos theta divided by sine theta, we'll again get 1 minus cos theta divided by sine theta. So we know 1 upon sine theta is nothing but cosec theta, and cos theta upon sine theta is equals to cot theta. So therefore substituting the these values again, we'll get cosec theta minus cot theta whole bracket square. So which is nothing but the left hand side of the equation. So we have solved the right hand side and equated with the left hand side, and it is matching, hence proved. The second question, we have to prove cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A is equals to 2 sec A. Now here we don't have anything to solve on RHS, so we are going to solve the LHS and we are going to equate the LHS with the RHS. So we have to take the LCM as cos A into 1 plus sin A in order to solve this ahead. So we'll get cos A into cos A divided by 1 plus sin A into cos A plus 1 plus sin A into 1 plus sin A divided by cos A into 1 plus sin A. Now here let's understand that 1 plus sin A into 1 plus sin A is nothing but the 1 plus sin A whole bracket square, which comes from the method a plus b into a plus b is equal to a plus b square. So we'll get cos square a plus 1 plus sin a bracket whole bracket square divided by cos a into 1 plus sin a. Now we are going to split this 1 plus sin a bracket square using the method a plus b square is equal to a square plus b square plus 2ab. So post substituting the values, we'll get cos square a plus sin square a plus 1 plus 2 sin a divided by cos a into 1 plus sin a. We do also know the trigonometric identity, which is sin square a plus cos square a is equals to 1. So substituting the value, like replacing the cos square a plus sin square a by 1, we'll get 1 plus 1 plus 2 sin a divided by cos a into 1 plus sin a. So next step, we'll get 2 plus 2 sin a divided by cos a into 1 plus sin a. Now we are taking 2 as a common in the numerator, and we'll get 2 into 1 plus sin a divided by cos a into 1 plus sin a. Now we can see the similar values are reflecting at the numerator as well as at the denominator. So we are going to cancel out. So that value is 1 plus sin a. So after cancellation of 1 plus sin a, we'll get, or we're left with 2 divided by cos a. Now we know 1 divided by cos a is equal to sec a. So we are going to substitute 1 by cos a to the sec a, and we'll get LHS is equal to 2 sec a, which is nothing but the RHS, hence proved. Now in question number 3, we have to prove tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta, which is equals to 1 plus sec theta into cosec theta. Now, by looking at the question, the right hand side of the equation, we can see it consists of sec theta and cosec theta, which can be easily converted into cos theta and sin theta. So the values are in terms of sin theta and cos theta, you can say. So looking at it, we have to convert the LHS values in terms of sin theta and cos theta. So we know that tan theta is equals to sin theta divided by cos theta, and cot theta is equal to cos theta upon sin theta. So we are going to substitute the value into the LHS. We'll get sin theta upon cos theta divided by 1 minus cos theta upon sin theta plus cos theta upon sin theta divided by 1 minus sin theta upon cos theta. We are going to take the LCM here and we will solve it ahead. So post solving it, we'll find sin square theta divided by cos theta into sin theta minus cos theta minus cos square theta divided by sin theta into sin theta minus cos theta. Now again we'll be taking the LCM as sin theta into cos theta into sin theta minus cos theta, and we'll get sin square theta into sin theta minus cos square theta into cos theta divided by sin theta cos theta into sin theta minus cos theta. So we'll get the numerator as sin cube theta minus cos cube theta divided by denominator same previous step. Again, We know that a cube minus b cube is equals to a minus b into a square plus ab plus b square. So therefore, applying the same method on sine cube theta minus cos cube theta, will get sine theta minus cos theta into sine square theta plus sine theta cos theta plus cos square theta. And again the same denominator. Now we can see the numerator and denominator consist the same value, which is sine theta minus cos theta. Let's go ahead and cancel it out. And the next step, you can also see the sine square theta plus cos square theta is nothing but the trigonometric identity, which has the value 1. So replacing sine square theta plus cos square theta by 1, will get 1 plus sine theta cos theta upon sine theta into cos theta. Here we are going to separate the, or we are going to break the numerator part. So we'll get 1 upon sine theta cos theta plus sine theta cos theta upon sine theta cos theta, which will make us which will allow us to cancel the sine theta cos theta, which is reflecting in the numerator as well as denominator. So let's go ahead and cancel it, and we're left with 1 plus 1 upon sine theta into 1 upon cos theta. So we know 1 upon sine theta is cosec theta and 1 upon cos theta is sec theta. Okay, so hence we have just substituted the values, and we'll find 1 plus sec theta into cosec theta, which is nothing but the RHS of the equation, hence proved. Question number 4, we are going to prove 1 plus sec a divided by sec a is equal to sine square a divided by 1 minus cos a. Now these type of questions, we have to solve the LHS and RHS both the sides in order to equate the LHS and RHS. So let's go ahead and solve the left hand side, which is 1 plus sec a divided by sec a. So we know sec a is equal to 1 upon cos a. So substituting the values into the LHS, will get 1 plus 1 upon cos a divided by 1 upon cos a. Now here numerator part we have solved, that is cos a plus 1 divided by cos a, because we have taken the LCM as cos a, into cos a divided by 1. Now it came from the denominator of the previous step, which is 1 upon cos a. It was dividing the numerator, and then if we'll multiply it, it will reverse its order. So 1 upon cos a will become cos a divided by 1. So we're left with the left hand side 1 plus cos a, post cancelling the cos a, which is the similar value reflecting at the numerator as well as denominator. So let's make LHS is equal to 1 plus cos a is as an equation 1, and also let's go ahead and solve the right hand side quickly. So we have the right hand side equals to sine square a divided by 1 minus cos a. So we know the trigonometric identity, that is sine square a plus cos square a is equals to 1. Using this identity, if we shift the value of cos square a to the other side, we'll get sine square a is equals to 1 minus cos square a. Substituting the value in the place of sine square a, we'll get 1 minus cos square a divided by 1 minus cos a. Now here the square of 1 is also 1, and the square of cos a is cos square a, which means this is 1 square minus cos square a. So we can use the formula a square minus b square equals to a plus b into a minus b. Using the same method, we can write 1 minus cos a into 1 plus cos a divided by 1 minus cos a. Now we can see the similar value reflecting again, which is 1 minus cos a. Let's go ahead and cancel it out, and we're left with the right hand side as 1 plus cos a, making it as an equation 2. So by equating the values of left hand side and right hand side using the equation 1 and equation 2, we get the same value, which is 1 plus cos a. So therefore we have proved it. Thank you.